morning students. Chapter 4 moving charges and magnetism. Yes, we will see some questions today. Exercise 4.16. You are given a circular coil of radius r having turns n and current I. And yes, you know that what is magnetic field on axis at distance x from center. B is equal to mu 0 NIR square upon 2x square plus r square plus 3 by 2. That is equation of magnetic field on axis at distance x from center. Okay, what is question A? What is magnetic field at center? Yes, we have already discussed about it. At center, x is equal to 0. So if you put x is equal to 0 in this equation, what you will get? B is equal to mu 0 ni r square upon 2 0. R square is 3 by 2, means it is r cube. Square cut, so it is mu 0 ni upon here it is 2. Simple. What is second question? Two parallel coaxial rings separated by distance r show that the field on axis around the midpoint is uniform over a small distance and is given by B is equal to 0.732 mu 0 ni upon r. Again, two parallel coaxial rings separated by distance r. See, here it is. One ring, its axis. It is another ring having same radius. It is midpoint. Yes, these two rings are separated by distance r. Its radius r. Coaxial, and that current is flowing in same direction. So that current is flowing in this same direction. Current is flowing in this same direction. As it is midpoint, okay, I can say this distance is r by 2, and yes, it is also r by 2. But you do not have to find magnetic field at midpoint. See, show that field on axis around the midpoint is uniform over a small distance. Around the midpoint. So yes, I am taking one point. That it is point P, and at this point P you have to find magnetic field. Around the midpoint is uniform and over small distance. So yes, I am assuming this distance D. Clear about this? Let it is coil 1 and let it is coil. Okay. So now at point P, first of all we will find magnetic field due to coil 1. Then we will find magnetic field due to coil 2. Okay. So let at point P at distance small d from center, where small d is very less than its radius. We want to find magnetic field. Let at point P at distance d from midpoint. It is from midpoint. We have to find magnetic field. So first of all, at point P we will find magnetic field due to coil 1. Okay, due to coil 1. Yes, we have equation. B is equal to mu 0 NIR square upon 2x square plus s square raised to 3 by 2. For this first coil, it is its center. What is this center to distance of point P? See, this whole distance is r by 2. Yes or no? This distance is r by 2. But we want to find only this distance. Then from figure it is clear. It is r by 2 minus e. Yes or no? Yes, it is r by 2 minus e. Okay, so here x1 is equal to, it is r by 2 minus e. Any doubt about this? Sure. Again, we want to find magnetic field at this point. So what is distance? Here it is. This distance is called x1. Okay, so what is x1? R by 2 minus t. Clear about this? Now put in equation. See, due to coil 1, magnetic field B1 is equal to, put value in equation, that is mu 0 ni r square upon 2 x1 square plus r square raised to 3 by 2. And it out. Now put value is equal to mu 0 ni r square divided by 2 in bracket. x1 is equal to r by 2 minus d. x1 is equal to r by 2 minus d whole square plus here it is r square and whole raised to 3 by 2 and whole raised to 3 by 2. Now you have to simplify this term. See how to simplify. b1 is equal to mu 0 ni r square. This term as it is. Okay. Now how to simplify this term? See 2 outside bracket. In bracket, yes, you have to simplify this a minus b whole square means a square minus a square plus b square minus 2ab. So yes, it is r square by 4 x square, okay, plus b square, okay, and minus it is r by 2. So yes, it is 2ab a square plus b square minus 2 means it is 2 r by 2b. Clear about this? So yes, this term is simplified. Plus here it is r square raised to 3 by 2. And it out in this equation. Clear about this? Okay. Now this distance d is very less than r, very small than r. Then yes, as d is very small than r, then here we can take this square nearly equal to 0 and this 2 cut and rd also nearly equal to 0. Clear about this? Then what is remaining? b1 is equal to, here it is mu 0 ni r square divided by, here it is 2. Yes, this term cancel out, this term cancel out. R square by 4 plus r square. R square by 4 plus r square means it is 5 r square by 4. Here it is 5 by 4 r square raised to 3 by 2. Raised to 3 by 2. Any doubt about this? Any doubt about this? Okay. Yes. Now it is magnetical only due to first point. Now due to second point. See. Now due to second point. Okay. Due to second point. It is its center. From this center to point B, what is distance? Yes, you can easily say, sir, it is r by 2 plus d. This distance, see this distance, it is r by 2 and this d. So yes, x2 is equal to, it is r by 2 plus d. Then if I write similar equation, I can write b2 is equal to mu 0 and I r square upon 2 x2 square plus r square is to 3 by 2. Clear? Now put value of x2. So is equal to is mu 0 ni r square upon 2 in bracket. Here is x2 means r by 2 plus d whole square plus r square raised to 3 by 2. And it out. Okay. Now simplify this term. Is equal to mu 0 ni r square divided by, here it is 2. Okay. It is r square by 4 plus d square plus 2 r by 2 d plus r square and whole raised to 3 by 2. Like this, only there is one change. Clear about this? This 2 cut. Again, this d square is nearly equal to 0. Also, this rd is nearly equal to 0. Then what is value of b2? b2 is equal to, it is mu 0 ni r square upon 2. This term cancel out this term. R square by 4 plus r square means it is 5 by 4 r square whole raised to 3 by 2. Clear about this? Now, magnetic field due to first coil, magnetic field due to second coil, but we cannot add them directly. First of all, we have to check direction. Yes, see, for this first coil, current is flowing in this direction, means V1 is in this direction. Yes or no? Yes. In this coil, current is again flowing in this direction, means V2 is in this direction. Yes or no? See, this V1 and V2, they are in same direction. Yes, V1 and V2 are in same direction. Here V1 and V2, here V1 and V2 are in same direction. And therefore, resultant magnetic field, B is equal to, here it is V1 plus V2. Here it is V1 plus V2. Yes, what is value of V1? Here it is. What is value of V2? Here it is. Okay, it is equal to, it is mu 0 Ni r square upon 2 5 by 4 r square is to 3 by 2 plus mu 0 Ni r square upon 2 5 by 4 r square is to 3 by 2. So yes, you can say this mu 0 Ni r square divided by 2. See, it is 1 by 2 plus 1 by 2, so this is 2. It will become 1. Okay, how to write this term? See, 5 by 4 r square is to 3 by 2 means I can write 5 by 4 raised to 3 by 2. Yes or no? Okay, r square raised to 3 by 2, the square and square root it cancel out, so it is r cube. So it is clear about this. Now this r square and here this cube. So if you simplify this 5 by 4 raised to 3 by 2, how to simplify this 5 by 4 raised to 3 by 2? First of all, take calculator. 5 by 4, you will get your answer. Then 5 by whatever your answer you will get, multiply 3 times. So it is cube and then square root. You will get your answer. What is your answer? Your answer is, it is 0.72. Numerator mu 0 Ni, in denominator it is r. In denominator it is. Clear about this? So yes, it is one question based on magnetic field due to circular loop. And yes, you have to remember this equation. Clear about this? Okay, write down. Now next question, exercise 4.16. You are given two coils in vertical plane, means in north-south direction. Coil X and Y. Radius of coil X 16 cm, number of turns 20, current flowing is 16 ampere in clockwise direction. While for coil Y, radius is 10 cm, number of turns 25, and current is 18 ampere, and current is flowing in anti-clockwise direction. Observer looking the coil facing west. Then your question is, what is resultant direction? What is resultant magnetic field? See, two coils. Yes, it is east and it is west. Yes or no? Yes. Plane of coil, it is like this. It is plane of coil in north and south. Two coils. First coil. So Rx is 16 and Ry is 10. So obviously it is X coil and it is Y coil. Clear about this? In Rx, current is flowing clockwise like this. See, facing west means observer is this side, facing west. Okay, this plane is actually like this. Two rings are like this. Clear about this? Okay, these two rings, this plane is actually about this in vertical plane, like this in north-south direction. Okay, so yes, these two coils are like this. Okay, X and Y. In coil X, current is flowing in clockwise direction, means in this direction, and in this Y, it is in anti-clockwise direction. Then we have to find what is resultant magnetic field at center and in which direction. So see, we will find. Okay, first of all, magnetic field at center due to coil X. Magnetic field at center due to coil X. Bx. At center means what is equation for center? It is mu 0 Ni upon 2r. It is mu 0 Ni upon 2r. Yes, here you have to write Nx, Ix, Rx. Simple. Okay, mu 0 means it is 4 pi into 10 raised to minus 7. What is value of Nx? It is 20. What is value of Ix? It is 16 divided by what is 2? That is 2. Rx is 16 centimeters, then it is 0.16. Okay, and yes, if you calculate this, you will get your answer 4 pi into 10 raised to 4 pi into 10 raised to minus 4 Tesla. 4 pi into 10 raised to minus 4 Tesla. Now what is direction? See, here it is. Here it is. I am facing west. Observe, it is facing west. It is facing west. In a coil X, current is flowing in clockwise direction. Clockwise direction means in this direction. See, in this direction. So thumb is going in west direction, towards west. So yes, magnetic field due to X coil is towards west. Is towards west. Clear about this? Again, in X coil, current is flowing in clockwise direction, like this. Like this. So yes, thumb is in western direction. So yes, towards west. Now I will find magnetic field due to coil Y. Magnetic field due to coil Y. Magnetic field due to coil Y. Okay, Bx. It is in this direction. Bx. Now magnetic field due to coil Y. What is equation? By is equal to mu 0 ny Iy upon 2Ry. Okay, now put value. See, here it is. Mu 0, 4 pi into 10 raised to minus 7. Ny, what is value of ny? 25. Iy, yes, it is 18. Divided by, it is 2. And what is value of Ry? 10 centimeter, means it is 0.1. It is 0.1. Clear about this? Yes. If you calculate this, you will get your answer 9 pi into 10 raised to minus 4 Tesla. Okay. Now it is magnitude. What is direction? See, again, observer is facing west. In coil Y, current is flowing in anti-clockwise direction. Anti-clockwise direction. So this thumb is in east direction. So yes, magnetic field due to coil Y is in east direction, towards east. It is towards east. Clear about this? So yes, in figure I can draw like this. It is By. So from figure it is clear. X center, magnetic field due to Bx, due to X coil in western direction. It is in east direction. They both are in opposite direction. So resultant magnetic field. B is equal to, as they both are in opposite direction, we know the rule. I can write By minus Bx. Now, why Bi minus Bx, not Bx minus By? Because here By is greater than Bx. By is greater than Bx. So yes, By 9 pi into 10 raised to minus 4 minus what is Bx? It is 4 pi into 10 raised to minus 4. So is equal to, it is 5 pi into 10 raised to minus 4. Now what is direction? As By is greater than Bx, as By is greater than Bx, resultant direction is also towards east. So yes, this resultant magnetic field is towards east. Is towards east. Clear about this? So yes, in this question, as currents are flowing in opposite direction, magnetic field is also in opposite direction. Yes, if we change this question, the two currents are flowing in the same direction, then magnetic field's direction will be same. So here we have to write plus. Here we have to write plus. Clear about this? Same direction plus, opposite direction minus, any different direction, law of parallelogram. Clear? So in this lecture we have discussed about two questions based on circular coil carrying current and their magnetic field. Okay students, watch videos regularly, write your notes, solve your doubts, and yes, do share, like and comment our videos.